Hello everyone. Today we are going to look into what a decision tree is in data mining. The decision tree can be used either for classification or it can be used even for regression. It is a very widely used algorithm and today we are going to focus on the classification. Here the decision tree is nothing but a classifier. Okay. So consider it to be a model. What is a model? Whenever you pass a data, training data to an algorithm, it generates a model. The model is something which gets trained from the patterns that are observed in your data basis on the algorithm that you have provided. In the decision tree algorithm, which is a classifier, it is going to classify our data into categories, whether it belongs to class A or class B, for instance. So it is an entity which is learning from the patterns of the data. So once this model is ready, it has learned, it is trained, then you can use this for decision making. Now consider we have a model ready, our decision tree is ready, it has trained from the training data set that we have provided. Now it's time to test it. We provide an observation where we don't know whether that sample data that we are providing belongs to class A or class B. And this is what the model is now going to predict for us. Okay, it is going to split the data and it can split it in sets or subsets. This is how the decision tree will look like. It is just like a tree structure with root, branches and leaves. So these are the basic terminologies being used. A root node, a decision node. So it is the node from where the decision tree begins. Okay. So what happens at the root or what happens at each of the node is based on the attributes which are there in your data, some decision is taken. There are some conditions being validated or functions being executed, and the branches are nothing but the output of that condition. So I ask a question based on the attribute and I get an answer or yes or no, true or false, and accordingly I split my data. Okay. Further, you keep on splitting the data until you arrive at a stage where you cannot split it further. So here, as you can see, if it is true, it is going here. If it is false, it is going here. If it is true, another decision is taken, and then we arrive at the leaf nodes where we cannot split the data further. Leaf nodes are the final output. Okay, splitting is nothing but the process of dividing into subnodes based on the given condition. Yeah, this is what it is. We'll see in detail with an example. Let's take a simple example where we have a data set with different candidates, the job offer provided to them, and whether they have accepted the job offer or not. So we can see in this data set we have A, B and C, wherein we know what the salary was, what was the distance, whether the office was providing cab facility or not, and in this situation with this offer whether the candidate has accepted the offer or not. So this is our data set which we can use for training our model, because we know the answer over here whether it has accepted the offer or not. Now once we train our model or train our decision tree with this information, this data, it is going to create an algorithm. And once it is trained, once we have the model ready, whenever we pass an unknown observation where we want this answer, whether the candidate is going to accept the offer or not, the decision tree will be able to provide us with the categorization or classification. Now let's look at the decision tree which is generated over here. So this is our root node, right? From where the decision tree begins. First condition that is being validated over here is the salary criteria. Is the salary greater than 10K? If not, then in case if it is false, it is going to decline the offer. If it is true, do we have candidates who have straight away accepted the offer if the salary is greater than 10K in our data set? No. That's the reason it is again going to look into the other attribute, that is distance from home and office. If the distance is less than 10 kilometer, whether it is going to accept the offer or not. Okay, if the condition is false, then it is again going to decline the offer. But in case the condition is true, still we have a mixed data set of candidates who have accepted and rejected the offer in spite of both this condition being true. Hence, there is a necessity to look into other attributes to do the further categorization. So this breakup will continue unless and until we arrive at the leaf nodes where we have distinguished data sets. They either fall in the category of accepting offer or rejecting offer. Okay. So now the other condition that is being validated is office cap availability. If the office is providing cap facility, then the candidate is accepting the offer, or else in case it is false, it is declining the offer. That is how this decision tree will work. Now you may argue that if it is simple if else conditioning, how does machine learning come into picture over here? Why this is different? The reason is the attribute that is selected for splitting. Okay, which attribute should be selected? Which attribute should be selected in the beginning? Okay, why they have selected salary attribute first? Why not office cap facility availability? So all these decisions are made based upon Gini index or entropy that is being calculated at each row. So that is something we'll cover in our next session, which will help you to understand this concept in a much better way.